This chisel needs sharpening. It has several large nicks in the blade, and of course where the nicks are in the blade leaves a flat spot and bulldozes the material in front of it instead of severing it. There you can see the flat spots in the metal. So this chisel needs sharpening. In this video I show you what I tried over the years and what I ended up with, because I rejected the previous ideas one by one. So first I tried oil stones. Oil stones of course need honing oil, and it makes everything messy, so it needs a special setup. I abandoned using oil stones. They cut fantastically well and they will make the tools sharp, but I just hate them. Next thing I tried was water stones, Japanese water stones, and then Norton stuff. And this stone used to be there, this thick. Okay, it just wore, yeah, one side is completely worn away and the other one is flat too. There, over time, because water stones wear a lot faster than oil stones. Yeah, water makes rust. Here on the chisel surface you can see some pitting. It's going below and into the surface so to remove this kind of rust from the tool, this very fine pitting would require removing the whole layer of metal to the depth of the pitted surface, so not worth it. Water stones work fantastically well as well. Rusting is you have to watch out for it and immediately dry everything, or often dry everything, so it's a little bit of a problem there, although it was less inconvenient for my liking than oil stones. However, water stones wear faster than oil stones, so I ended up water stones need truing, oil stones need truing as well, and for that you need a truing stone that's a coarser grit and a harder material than the stone you're working with. When it comes to truing, this is what I mean. You see how the middle of it is dished out? You can see underneath the edge there that it's not touching the stone. Maybe even closer. There. It's not touching the stone there. Let me just focus the camera. There. It's touching the stone at the end and at the other end. Okay, so I have a dish here in the middle, and it's unavoidable. Uneven wear is just unavoidable. On crosswise looks fairly reasonable, although I'm trying to look through the camera. Let's see the other side. That end looks good. Yeah, at this end you can see underneath there, let's make it underneath the number 9, that you have a little bit of a gappage between the stone and the blade of the combination square, somewhere around the number 9, which is now upside down. Oh no, it's not. Alright. So these stones need truing all the time, and because otherwise it's gonna make the blade that you're making either curved or concaved or whatever. I want flat blades. So what I ended up using after years of experimenting with different shapes and materials and stuff, I ended up with float glass. Just float glass like this. It's a piece of flat glass. Make sure it's float glass, not rolled glass. And I glued to it adhesive like that, 80 grit adhesive paper, and I have this little tool from or gauge or guide from Lee Valley, into which I can mount a chisel that maintains an angle I'm happy with. Let's do it this way so you can see what this is all about. Come on down a little bit. We'll get you a nice viewing angle here. So let's try it here. Mount the chisel just like so, just roughly initially. Okay, I want to do it this way around, sorry. and then you just have to match the bevel on the chisel to the bevel of the surface you're gonna be riding it on. So there, that would be a good match. Let's make a close-up on this one. There, you got the idea. Let's try it on glass. Yeah, that's pretty good. Oh, I see, it's gonna be cutting from the edge more than from this surface. That's good, you know, I'm gonna be happy with it. Or I can adjust it just ever so slightly. How about there? Okay, let's check out that one. That's better. Alright. And all you need to do is, so this one is 80 grit. Yeah, I ended up with dry honing, as you see. It's a little bit off. Maybe I should square it a little better before I go any further, but you get the idea. The fastest and for me least inconvenient way of honing chisels at a consistent angle. So that's basically all I wanted to share about this. So after just a few strokes, you can see the edge of the chisel is being worn away towards the high point here. So I'm wearing only the front end of the bevel edge. Of course, first thing I did was I squared this little jig to the blade here. That's what the combination square is for. And the finished edge on this will be between 20 and 25 degrees. Let's see, there is 20, there's 20, and there is 25. So there, let's get a little closer. There you can see it's gappy at 25 this way, and it's a little better fitting at 20, but so it's between something like that. This is my only chisel that has such a long bevel cut on it. One more thing, power grinding. Yeah, why don't I do it on a grinding stone? Because the grinding stone is a circle, and I don't like the circle shape it's gonna make. It's gonna make the bevel, you can see it's flat now, or close to flat with that little bit. Just ignore that little bit of angular difference there. Okay, you get the idea. It's gonna make it curved, so that means that, or it's gonna make it concave, so that means that at the edge where the edge needs to be supported by the metal immediately behind it, that's where it's gonna be the weakest. It's gonna make a really thin edge. Okay, it's pretty much a geometric. It's unavoidable. Okay, it's a geometric impossibility not to have the metal at the edge the thinnest, the most vulnerable to chips and whatever. Of course, you can have a larger radius or larger diameter honing or grinding stone, but it's always going to be curved. Okay, it's never going to be as flat as float glass. Alright, so this one is not only a problem with the mathematical shape of the edge that it produces, but also overheats the metal that's being worked on. So for these two reasons, even though I have a grinder right there, this is the grinder with its light, yeah, it's not happening. So I'll get back to float glass. Just give me a few minutes. Seriously, I only worked on it less than 45 seconds. Shape is coming along fine. It's only been
a minute and a half into it. And I'm almost done. I make one pass moving along the glass surface. Remove grip with compressed air, super simple. And then take a look at the result. You can see that in a minute and a half, seriously, the nick is almost entirely removed. We can even call it close enough. There's a huge burr, of course, on the back side on account of the 80 grit. Of course, there is the burr. And of course that needs to go, but so far, like seriously, it was a minute and a half of regrinding the chisel's shape. So I know there are other grinding stones that are softer, and there's one more kind of grinding, this kind of grinding where it's flat, it's spinning flat like so. You can get different it's a disc that's flat enough. You can get different grit of sandpaper to it. You know, this stuff is expensive. I don't like it. I got finer ones. I got different discs here. This one is the cheapest that I ended up with by far. And let me just rotate. So dishing out the surface is not an issue here. The cheapest so far I've found, and it doesn't need fancy equipment or power equipment or anything. Alright, just give me another minute, I'll finish this. In the meanwhile, I just flipped the float glass over. This side is where I glued the 120 grit sandpaper on, and this is how progress looks like. Let me just get you a nice sharp picture thereabouts. Okay, you can see that the bevel is taking place, and there's the burr along the edge. That's gonna be removed later. So that's how it looks so far. It's been completely reground in a span of 3 minutes. Back to this one, I looked up the prices. One disc is $5, and you can see it's this big. However, this kind of stuff comes on a roll, like so. Discs and rolls are available at Lee Valley. That's where I get them from. LeeValleyTools.com. So you can get these rolls, 220, 120 and 80 grit, adhesive backed PSA, pressure sensitive adhesive, PSA backed aluminum oxide grit, abrasive rolls. You get 30 feet, that's 10-meter long roll. You do the math with the surface area. This is 30 feet or 10 meters long for $20 includes taxes, and this is a single disc is $5. So you do the math on that one, okay? I'm sticking with these rolls, and I'm done with 120, so I'm switching over to 220. There's my 220. We're almost done. So I'm done with the 220 grit. This is how the progress is looking. It's not quite a mirror polish yet, but for a general purpose woodworking chisel, you know, all the nicks have been thoroughly ground out, and this is how metal surface looks like with 220 grit polish. There's a little bit of burr edge on the back side here. I'm gonna remove the last a bit with the last grit of sandpaper. So done with the 220. So what comes next? Oh, prepare to be amazed, my friend, because what comes next is no adhesive sanding, just plain sandpaper. I don't know, 30 cents a piece, whatever it costs. 320, 600 grit, 1000 grit, 2000 grit. How fine of a mirror polish do you want to put on that chisel bevel face? I don't know. Let's try 300, because these are micro finishing grits. They don't need to be glued to the glass. They will stay in place just as is. Okay, so just give me another minute on this one. So I'm done using the 320 and the 600 grit papers. This is how the bevel looks like. It's highly reflective now. There.
You can kind of see the camera's body in it, reflecting the lens. You can see the door frame in it. You know, you get the idea. And I'm just talking about this bevel surface here. Alright, it's coming along. So let's give it a try with the 1000 and 2000 just for show and tell. Give me another half a minute here. So I'm done using this jig. I'm done with the bevel. Let's take a look at the bevel. What have we accomplished? There you can read the camera's lenses numbers if the camera focuses enough on it, and of course it's a mirror image of what's printed on it. So this is a Panasonic lens. You can see my fingers, fingernails, everything sharply, or the reflection on the chisel's bevel. So do you need this kind of mirror polish on the chisel's bevel? Maybe you don't, so then don't do it. However, one thing about a polished metal surface, it rusts less, or it rusts later. There's my ear. So because the microscopic surface unevenness has been greatly reduced, in which water molecules or droplets, microscopic droplets, can cling to and start pitting corrosion. Okay, so this metal edge is and this bevel surface will last longer than one that isn't highly reflective, like any of the, I don't know, any of these other surfaces. So I still have to do these two plane blades and that chisel, and I still have to lap this surface on the chisel. It's not too bad, but I still have a little bit of metal burr on this side. So let's see what else has been accomplished other than highly polished reflective surface. Of course, the edge is square to the side. That's very important. There, that's pretty good. There's a little bit of gappage there. Yeah, a little bit underneath the number 1 there in the kind of middle of the picture. Yeah, it's close enough to being square to the side of the chisel. That's important. The edge and the metal didn't get burnt. We didn't use power tools, so the hardness, the steel did not get tempered. Its hardness was not compromised. This is a high carbon steel, and which has been hardened by quenching and subsequent tempering. If you heat it up, if you put it on a grinding stone, not only the edge will be dished out and concave, and its cutting edge made weaker by this concave surface, by making the edge the thinnest on the blade, but will also overheat, so we avoided overheating by doing everything on manual power. Not only the shape, but also the qualities of metal and the hardness of metal has been meticulously preserved by doing everything on manual power. And we have a 25-degree or close enough to 25-degree finished bevel angle. Let me just focus the camera. Just give me a sec here. There we have it. Alright, that's close enough to 25 degrees. If it was less than 25, yeah, 20, no. Anything less than 25 is just impractical for severing wood fiber, really. It's not a razor blade, it's meant and designed to sever wood fiber. For that reason, I'm not even gonna try to shave with this or split a piece of paper with it. It's not meant to split papers in normal operation. This is not a scissors. So it should sever wood fiber in mounting hinges and cutting the hinge gain and lock sets and some such thing, or mortise and tenon joints. Alright, so that's that. We kept cost at minimal by using cheap sandpaper, and some of it was adhesive backed, but yeah, it doesn't need a power supply, it doesn't need fancy equipment, it really just needed this single jig. So that's basically the wrap. Thank you very much for watching. I know it's a long video. You can create a similar finish quality edge in say about 6 to 9 minutes. It's about 2 to 3 minutes to run it through 80 grit and 120 grit. That's the grinding phase of the chisel, reaching its basic, or forming its basic shape, and then 2 to 3 minutes with the 220 grit and the 320 grit, and then the micro finishing grits, 600, 1000, 2000. Give it another 2-3 minutes, so that's why, you know, total of 6 to 9 minutes you should have a decent chisel done without any use of power tools. So thank you very much for watching. Let's get to work now. Alright, let's do a last check after I've done all honing on all sides. Oh yeah, safety note, watch your fingers, don't cut your fingers. I cut a few holes in the paper. That happens. I'm not saying that's unavoidable, that happens. Alright, let's take a look at this chisel situation here. So that's nicely lapped. You can see some of the parts are hazy to different degrees. So where it's hazy, that means I did not remove some of the deeper scratch marks that comes from manufacturing the chisel in the first place. Why not? Because this one is a deeper surface, is dished out here at this corner here, and I didn't want to remove all that thickness of metal to just get to the bottom of this dish there. Alright, so that's why. However, at the edge here, it's very nice. You do need to have no hazy area here at the cutting edge, so that the edge is actually geometrically, you know, it's a triangle with all of its parts supporting the cutting edge, with no dished out areas, okay, nothing hanging in the air. So when you push the chisel forward, all of the cutting edge comes into contact with the wood fibers at the same height or depth, or whatever way you look at it. So I have also touched up the edge like so, and this little bevel surface there, that bevel surface is there. The same stuff applies. You can see some parts of it here more highly polished than some other parts of it. This chisel is made by this chisel is hardened by quenching it, so that means heating it up to red hot or whatever temperature. Just envision it that this is red hot and it's plunged into cold oil or cold water. Metal shrinks unevenly in this quenching process, so that's why some of the areas you have some high spots and you have some low spots. Alright, that's pretty much unavoidable and needs or could be removed by lapping all surfaces until it's mathematically flat everywhere. Unnecessary. It needs to have a good cutting edge. So that's it, end of the story.